Okay, so solving one-step inequalities. With this new added note sheet, what I would make sure you do after we take the notes today is that you add these to your other notes. I would keep them in order, so I'd make this the last spot in your notes. So you should, I think this is your fourth note sheet. So this should be the fourth spot when your notes are all combined together. Now, solving one-step inequalities. Yes? Huh? So what do you guys think? So Darius asked, are we going to have a test or something? So what do you think this Friday, when we do our quiz, what do you think Friday's quiz is going to be over?
This.
Yeah, solving one-step inequalities. Now, our big test is going to be September 22nd. I'm pointing at the back calendar here. So September 22nd, if you notice, it's end of first triad. So we only do tests once a triad. We do quizzes to check your understanding every week. Now, we won't take the test on Friday. We'll probably start it on Wednesday or Thursday. One, to make sure everybody has time to finish. And two, if you happen to miss one of those days, make sure that we can catch you on the other days to make sure you get it all finished. So, okay, so solving one-step inequalities. So fill them out on your notes. An inequality is like an equation, except instead of both sides being, what do you think we're going to plug in there? Instead of both sides being, so when you do a one-step equation, you have this. Yeah, so instead of both sides being equal, one side is blank than the other. So if I have this, if it's not going to be equal, I'm going to throw that inequality sign. So one side is going to be what than the other? Greater than. Perfect. Oh, you have than. Oh, yeah. Thank you. See, I'm telling you guys. You have to keep me on my toes today. All right, we all have it down?
Stop singing the song.
Rihanna and Darius. All right, let's take a look at the next one. In its strict inequality, the two sides cannot be good. The two sides cannot be equal. So these two types of strict inequalities are I'll give you a hint.
Less than or
Yeah. So the first one is going to be greater than, because remember the alligator eats the larger one, so the greater than and less than. So the alligator is going to be our inequality sign. Pac-Man. Okay. In an inequality that is not strict, so strict, it's either greater than or less than, but inequality that is not strict, the two sides can also be equal. So it's going to look a bit different than a strict inequality. So these two types are, I'll give you a little hint. So these two types are, what do you think?
I know this.
Rihanna? Well, here, break it down. Look at your inequality sign. So ignore this. So what's that mean?
Ain't that greater?
Okay, so is greater than, so our greater than, or what's this bottom one mean? What's that part of?
It's like division.
No, what's that part of? Help her out, Deontay? Yeah, so these two types are greater than or equal to. So you have the combination of the signs. So you have greater than, and then you put part of the equal sign or equal to. And the other one is going to be what then?
Less than or
Yeah, less than or equal to. Okay, we get them down. All right, so let's take a look at some practice problems. Oh, sorry. Last thing. So, solving inequalities is like solving equations with a couple of exceptions. Exception number 1, instead of an equal sign, we're going to use the inequality symbol. So when we go to do examples 1 through 4, instead of a plus 3 equals 7, you might have a plus 3 is less than 7. So, example number 1, a plus 5, how would I read this sign? Is greater than 10. Solve it just like a one-step equation. We're going to circle our variable. We're going to draw our line of equality. We still want to get the variable by itself. So, correct. I'm going to minus 5 on both sides. So we're still going to follow the golden rule. Whatever I do to one side of the line of equality, I must do to the other. I'm going to show that I bring my variable down. But this time, instead of writing an equal sign, what do I write on my line of equality? Yeah, greater than. And then I go ahead and solve. What's 10 minus 5? 5. And then I'm going to box it. If you guys get cold, let me know. I'm burning up, so I'm going to prop the door. So if you get cold, just let me know. So our answer is A is greater than 5. Okay. Let's take a look at example number 2. B minus 3, how do I read this sign? Is less than negative 5. Circle my variable, put my line of equality through my is less than sign. In order to get the variable by itself, what do I have to do here, Asia? So if I want to, go ahead. So if I want to get that B by itself, what do I have to do to it? I have to get rid of the minus 3, so I'm going to have to say it again.
plus 3.
Yeah, plus 3. So I'm going to add 3 to each side. 3's are going to cancel on the left. Bring down my variable B. What do I put on my line of equality? Darius? Yeah, the less than sign. Then what's negative 5 plus 3? Negative 2. Nice. Box my answer. Pretty easy, right? Yeah. You guys got this. Questions on the first 2? Okay, we're going to move right along then. Example number 3. So, the first 2 practice problems, were they called strict inequalities or not strict inequalities?
Not strict.
The first 2.
Oh.
Strict. The reason why they are called strict is because they didn't have that little equal sign underneath it. So example number 3 here, we have 35 is greater than or equal to 7c. So that's going to be a not strict inequality. Circle our variable, draw our line. Now we still want to get the c by itself. So as I believe Deontay said, divide by 7 on each side. I show that my 7's cancel. I bring down my c on the right side. What sign do I put on my line of equality here, Deontay?
Oh, greater than or equal.
So my greater than or equal to sign goes there.
Yeah.
And then what's 35 divided by 7? What's 35 divided by 7? 5. Questions? Okay. Did you guys do this last year with your class? Good. Example number 4. Strict or not strict inequality?
Not strict.
Not strict, because it's less than or equal to. So we have 12 is less than or equal to 3D. Brendan, how do I get the D by itself? Divide by 3. Whatever I do to one side, I must do to the other. I bring down my variable D. Then what sign do I need to put on the line of equality, Brandon? Can somebody help him out?
What?
What's the sign?
It's less than or equal.
It's less than or equal to. And then what's 12 divided by 3? 4. So my answer is 4 is less than or greater to D. I'm sorry. 4 is less than or equal to D. I misspoke there. All right. So then on the back side, if you notice, we're going to have a few more practice problems. Because sometimes you're going to have to flip your inequality sign around. So let's take a look at the back. So solving one-step inequalities. Solving inequalities is like solving equations with a couple exceptions. The exception number 1, which we covered on your first page of your notes, is that instead of an equal sign, we're going to use the inequality sign. So instead of always using equals, we're going to use our inequality signs. So that's our first exception. So we're not going to use that. We're going to choose one of those to use. Exception number 2. When multiplying and dividing by a negative, we're going to have to flip the inequality sign. So exception number 2. When multiplying and dividing by a negative, we're going to flip the inequality sign. So I'm going to give you one of these is we would flip, the other one we would not. What's the problem?
Your music still playing? I heard music.
So, exception number 2. When multiplying and dividing by a negative, you have to flip the inequality. So which one, number 1 or number 2, would I have to flip the inequality? Which one am I dividing or multiplying by a negative number?
You see what you gotta do.
So which one of these, 1 or 2, would I flip the inequality sign? 1, yeah. I'm multiplying, see how it's negative 2x? So I would have to flip this inequality sign. Now this one, my answer, my product here is a negative. So we wouldn't flip that inequality sign. So just on example number 1, would we flip that inequality sign when we go to solve? That's not the example you're going to write down though. Sorry guys. I should have been a little more clear on that. I just wanted you to see what I was talking about. Okay, so let's get into our next few example problems here. This is the example that you're going to write for example number 5. Negative 2e is greater than 10. So this is going to be one of our exceptions. I am multiplying here by a negative number. Because I am multiplying here by a negative number, what am I going to do with that inequality sign? I'm going to flip it. So the first thing I'm going to do so I don't forget is drop down here and flip that sign. Now, how do I get the e by itself?
You gotta add to.
Somebody correct him and tell him why.
You gotta divide by 2.
You're going to divide by what kind of 2?
Negative 2.
Oh yeah, you do. It is.
You guys are a mess. I thought I was out of it on this Monday. I'm hearing add 2, divide by positive 2. What's the right thing? Divide by negative 2.
Why would you say that?
Divide by negative 2. So my 2's cancel. I bring down my variable. I flipped my inequality sign. because multiplying by a -2 to get the e by itself, I divide. So e is less than, what's 10 divided by -2?
I did -5.
-5. Now remember, listen, this division sign could also be interpreted as a fraction sign. Let's say it was, you don't have to write what I'm writing in the red now. So let's say it was 10 over -3. Well, first of all, can you take 10 and divide it by -3 evenly? No, you can't do it. Do I want answers in a decimal form? No, I want it written as a fraction. So I need to write 10 over -3 as a fraction. First thing I'm going to have to do, can I simplify 10 over 3? No. Can I write that just how it is then?
Yeah.
Yeah?
No.
What's wrong with it? There is something wrong with it.
First off, it's an improper fraction.
I want to leave it as an improper.
Oh,
But you got a negative on the number.
you got negative.
You got a negative on the bottom, so what do I need to do with that negative, Nick?
Try to get into the top.
Nick, what do I do? Nick's the only smart one that got it right here, so you don't get to answer for him now. So Nick, what do I do with this negative?
2 times.
Nope, help him out, Deontay. Did you, wait, I think you might have said it, you might have just mumbled. What did you say?
Said times.
Top. Times or top?
Times.
No, help him out, Deontay.
You gotta try to get that one to the top.
So how do I get it to the top?
And don't you gotta like get another, put the other.
We're gonna help him.
Move it up.
Yeah, just move it.
All that extra.
It's just easy. It's the easiest thing you might be able to do.
I knew you had to get to the top.
That's all right. That's why we're a team in here. Team effort. All right, let's take a look at example number 6. Example number 6. Go ahead and write it down on your paper. 2f is greater than -10. Hey,
Oh, don't.
before we move forward, don't say a word. I don't want anybody to say anything. If you think we leave the inequality sign alone, put your head down. If you think we flip the inequality, stand up. So if you think we leave it alone, put your head down.
Oh, hold on, I'm confused.
If you think we're going to flip that inequality, stand up. Yeah, are you? I think he's just taking the lazy route. Okay. Those of you that are sitting, I'll get an extra credit point. Nice job. Yeah, no, I'm teasing. So, have a seat. Let's explain why.
Oh my.
Read your exception number 2 for me. Nick's going to read it nice and loud. Nice and loud.
That's equal to 10. They got a -10.
Somebody help him out. Beyonce, read exception number 2 for me.
You want me to read the problem?
No, because that's example number 6. I want you to read exception number 2.
Oh, when multiplying. Oh, when multiplying divided by negative flip the equality.
Okay. When multiplying or dividing by a negative number, flip the inequality. So let's look again. We're multiplying by a +2. It's not a -2, is it?
Nope.
We're multiplying by a +2. My answer is a negative. So because we're not multiplying by a negative on this side, though, the inequality sign stays the same. So we're going to go ahead and solve this normal. Asia, how do I get the f by itself? Bring the 2 down by showing that you're dividing it. So we're going to divide each side by 2. I bring my variable f down. We already discussed that we're not going to change our inequality sign. It's going to be f is greater than the -10 divided by 2 equals, anybody? It's going to equal 5. What kind of 5?
-5.
-5. That's going to be your final answer. Negative, stop and listen. A negative divided by a positive is a negative. If you guys refer to your cheat sheets, I think that we wrote in your folders here, it will tell you it's going to be a negative.
Okay.
All right, let's take a look at example number 7.
Oh my God. I see the same thing.
Now, it's written differently, and that's okay. Before you get yourself stressed out over it, you just have to stop and look at it. So stop and look at it, and then try to read it to yourself. So it's nothing different than what we've done before. We just haven't seen a problem like this in a little bit of time here. So if I was looking at this, I would say G divided by -3 is less than or equal to 10. So if I want to get that G by itself, what's the opposite of dividing?
Multiply.
So I'm going to multiply each side by -3. My 3's cancel. I bring down my G. Now, are we multiplying or dividing by a negative number?
Multiplying by a negative.
Just yes or no. Are we multiplying or dividing by a negative number?
Yeah.
Yes. So our answer is yes. Then this inequality sign, we're going to flip. So now it's going to be as G is greater than or equal to. Because we're multiplying or dividing by a negative, that's when you flip the sign. So then we go ahead and continue solving. 10 times -3 is going to equal -30. Excuse me. All right, let's take a look at example number 8. Circle our variable. Draw a line of equality. How do I get the H by itself, Kelsey? I'm going to divide by 5. My 5's cancel. I bring my H down. Here. Am I multiplying or dividing by a negative number? Yes or no? No. Since it is not a negative number, what happens to this inequality sign? It stays the same. So it's going to stay as less than or equal to. Now, using my calculator, if I take -8 and divide it by 5, am I going to get a whole number?
No.
You're going to get a decimal. So we're going to leave it. Stop. It's not an argument. Try it again. So we're going to go ahead and leave it as a fraction. So if I take -8 and divide it by 5, I'm going to get 1 point something. So because of that, I'm going to leave it as a fraction. So then I have to ask myself, can I reduce -8 over 5? No. So I'm just going to leave it as -8 over 5. And that's where we're going to stop today. We'll finish the next 2 example problems tomorrow.